Hello everyone. My name is Mangesh Bansod. I'm from second year aeronautical engineering and I'm here to present solid mechanics ISE number 1, which is conjugate beam method applied to tailplane deflection analysis. Coming to an introduction to our topic, the aircraft tailplane is a horizontal stabilizer at the rear of aircraft. Rear means at the tail side, and its functions are to provide stability and control in pitch, and experiences aerodynamic loads during flight. Problem is a tailplane deflects under loads must analyze for safety and performance. Why it is necessary for deflection analysis? So first is a excessive deflection, which says instability or control surfaces misalignment, and second is accurate deflection analysis ensures safe structural safety, pilot control effectiveness. Third is passenger comfort. And methods which are used to determine this is double integration and Macaulays and conjugate beam method. Now, what is a conjugate beam method? It is a structural analysis techniques to determine the slope and deflection within the beam, which principle states that it replaces the real beam with conjugate, which means imaginary beam, and applied loading as mass divided by E into I, where E and I's are constant, which is equal to the bending moment to which equal to the ratio of bending moment and flexural rigidity. And shear in a conjugate beam is equal to the slope in a real beam, and bending moment in a conjugate beam is equal to the deflection in real. Now, steps in conjugate beam method are follows. First, draw bending moment diagram of a real beam, and second is divide BM bending moment diagram by flexural rigidity means EI, which is a constant, to get its diagram. Third is replace a real beam with conjugate beam, which simply supported becomes simply supported, fixed end becomes free end, and free end becomes fixed end. Fourth step is apply M divided by EI diagram as load on conjugate beam. Fifth is analyze conjugate beam. Shear force is a slope in a real beam and bending moment to deflection in a real. Now consider the tailplane. Tailplane idealized as a beam, simply supported or cantilever. Simply supported means which is just a place on two means what can I say means two base and cantilever means it is fixed at one end, and aerodynamic lift force act as uniformly distributed load means UDL. It has governing parameters like a span of tailplane means length, load distribution Q, material property E, and cross section stiffness I. Now taking a example to solve the problem by conjugate beam method. The examples stated that tailplane span is given as 3 meter and load as UDL of 2 kilonewton per meter. Then we have to solve it by stepwise to understand. The first step is draw BMD of tailplane beam. Second step is divide by EI. Third step is construct conjugate beam with suitable supports. And fourth step is analyze shear and moment in conjugate beam to slope and deflection in the real tailplane. The given parameters are tailplane span means length is 3 meter, which is converted into mm, which becomes 3000 mm, and uniformly distributed load W is equal to 2 kilonewton per meter. This should be in a mm, so it becomes 2 Newton per mm. Then the EI, which is a constant, which values are 2 into 10 raised to 5 multiplied by, and I is equal to 10 raised to 8. which should be in a mm. So 2 into 10 raised to 13 Newton per mm square. Then step 1, reactions at ends. Total load is WL is equal to 2 into 3, that is total equal to 6 kilonewton. Since beam is simply supported, then the reaction at both the ends will be equal, and which is W into L, which is WL by 2, which is 2 into 3, 6 divided by 2 is equal to 3 kilonewton. Step 2, bending moment diagram. For simply supported beam under a uniformly distributed load, the moment at any point X is equal to reaction at A into X minus WX square by 2. Then the max bending moment at mid span is equal to 1.5. Then the maximum bending moment is equal to the WL square by 8, which found to be 2.5 kilonewton meter. Now steps 3 is divide by EI. So M by EI is equal to the W by EI into bracket LX square by 2 minus X square by 2. Step 4 is construct conjugate beam, which includes a real beam is equal to simply supported to conjugate beam is equal to simply supported. Then apply M by EI diagram as load. Then step 5 is for deflection and slope calculation, which includes shear force in conjugate beam is equal to the slope in a real beam, and bending moment in conjugate beam is equal to the deflection in a real beam. Then formula for maximum deflection is given to be 5 into W into L raised to 4 divided by 384 into EI. Let's substituting this value from given data, we get the maximum deflection to be 2.1093 divided by EI meter. Now substituting the value of constant EI is equal to 2 into 10 raised to 30 Newton per mm square to the maximum deflection equation, we get 1.055 into 10 raised to minus 4 meter as a deflection in tail plane of aircraft. Advantages of conjugate beam are which simplifies slope and deflection calculation, and it is used for beams with complex loadings. It provides a direct relationship between beam deflection and internal forces, and it is easy to visualize with conclusion of conjugate beam method is a, is a conjugate beam method is a powerful tool for aircraft structural analysis. It helps to predict the tailplane deflection accurately. It ensures structural safety and aerodynamic performance of aircraft, and it is widely applied in aeronautical engineering problems. All the information is collected from the book Strength of Materials by R.K. Bansal. Thank you for watching the video.